Alrighty then, here we go. We are now going to do part 2 of lesson 4.1, page 183 to 186. Just to recap, when we're dealing with writing out our different types of relationships, if we say something is directly proportional, when we say the cost is directly proportional to the number of breakfast, so it's like cos y is directly proportional, it's equal sign, directly proportional to number of breakfasts, in this case 2x. So this is the equation. That's what it looks like in an equation. If I'm looking at a table, and if I know that my rate is 2, so essentially this is going up by 1 each time. I like to write it right on the table itself, plus a 1. Here, between here is plus 2. Now, it's not always going to be an integer. Sometimes it's going to be decimals and fractions, and that's why you have to know how to do the math, because that's where it gets a little bit harder. And again, here we talked about going on our graphs. The number of breakfasts and the cost. Again, this is our independent variable. Right? Remember, I write as you write. The independent variable. It's our input. It's our x value. It's our domain. This is our dependent variable. It is our y value. It's our x value. It is our output. And it's our range. Okay, you have to know those things. If I ask you 3 or 4 ways to describe what's on the y-axis, you have to shout that out to me. So I could go to the constant rate. It's 2 costs for 1 breakfast, 2 costs for 1 breakfast, 2 costs for 1 breakfast. So that's our constant rate. We'll know that rate is the same no matter where I go, right? Okay, so going on to example 4 now. We're going to compare relationships. You have to compare all the different itty-bitties. So the distance y in miles, okay, y in miles, good, that's our output, that can be covered by a rabbit running fast. In input, this is our rabbit, okay, can be represented by the equation y equals 35x. Maybe it's 35 miles per hour. I don't know. That seems very fast for a rabbit. The distance can be covered by a grizzly bear. Oh, wait. Oh, this is the grizzly bear. This is the grizzly bear right here. This is the grizzly bear. Big fat fuzzy bear, okay? Big fat fuzzy bear is going here. Let's make that the phrase that pays. Phrase that pays. Fat fuzzy bear. Okay. Write that down. It's going to be in the same spot. Fat fuzzy bear. Okay, let's go back. Phrase that pays. Okay. So, and now you're going to turn off the bit. Don't turn it off. There might be another one. You never know. Okay. So now it says, when we want to compare the relationships, we have to decide. Well, this one here is going to be at a certain speed. The rabbit is 35x. All right, that means that's his rate. He's going at 35 miles per hour. Okay, because we know that distance y could be expressed as miles per hour. It tells us. So here's the grizzly graph, the grizzly bear's graph. So now I have to find the speed of the grizzly bear. So now we have to find the slope. Well, if I'm going to go through here, 1, 2, 3, I can just count on the graph. So I could count on the graph up to right 1. So my vertical movements, my change in y, change in x, I go up 30, right? 10, 20, 30, 10, 20, 30, or 60 minus 30 is also 30, and to the right 1, right 1. Remember we talked about up and to the right is always positive, and down and to the left is always negative, okay? So looking at signs, that's what it looks like. So I'm going to say his rate is 30 over 1. Now the other way of doing it is by, and do they show this to you? Let's see on the next page. Yes, is by subtraction. So the other way of doing it, if I'm taking a look at my ordered pairs, this is x, that's y. This is the second x, so the second y. How come it's the second one? It's what I saw last. So here's my first y and my first x. So that's just to highlight those bad boys. So if I'm looking at this, I have to fit my change in y. So I'm going to go 30 minus 60 over the change in x, 1 minus 2. So change in y over change in x. That gives me a negative 30 over negative 1, or positive 30. So that would be another way of finding the slope. Let's see how it's detailed over here. Same exact way. They just changed it a little bit. I had put this other guy's first. Same answer. You're still going to get the same answer as 60 divided by 2, which is 30 over 1. Okay? So we were able to caught them up, and we're able to do the subtraction. So if I'm looking at use of point, okay. So what's the use of 0.1r on the graph? What does that mean? On the graph, when the y-coordinate is 30, when x is 1, so I go back here, the y-coordinate is 30. Okay, that makes sense. Okay. Oh, x is 1. Did I say that out loud in my head? Yeah, I said that in my head. Okay. The 0.130 represents the unit rate, which is 30 miles per hour. So the other one, just the unit rate, just finding out what this is. If I go from here to here, here, it's still the same thing, unit rate. That's what I mean. Okay, 1 unit. So since 1 is a unit, and our units are by ones, so it's 1 unit. I'm at 30. That's another way of figuring it out. Okay, so that's the third way, but I wouldn't rely on that so much. So if I compare it, which one's bigger? Well, the rate for the rabbit is greater than the rate, so obviously the rabbit, duh. Okay, that's just like stupid. Okay, right now, do the checks, and then we'll go over the checks in class tomorrow. Okay, so I lied. So let's take a look at this. So here, and the answer is a cat. So here the dog is y equals 1/2 x. Okay. Now we have to find out what the cat is. This is the cat's. So I did a couple things. One, I just counted on the graph, but I wanted you to look at this graph. This graph is up by 2s. 2, 4, 6, 8. Who do we appreciate? So as I'm going up by 2s, it means I'm up 2 and right 1. So I wrote this down, up 2, right 1. Up 2, because it's 2 units, 6 from 4 is 2, 3 to 2 is just 1, up 2, right 1. So my rate is here, my slope is 2 to 1, 2 over 1. So my m is 2 over 1. The other way of doing it is picking up 2 ordered pairs. I picked 4 and 8 and 2 and 4. So 4 and 8, 2 and 4. 4 and 8 I pick first, so x sub 1, y sub 1. 2 and 4 I pick second, x sub 2, y. That's the only reason why. So then I subtracted the y's, change in y, so I did change in y over change in x. So I did 4 minus 8, no particular reason, and then because I did 4 first, that means I have to do this 2 over here first. I did 2 minus 4. So 4 minus 8, they've got to match up, 2 minus 4, meaning first ordered pair, second ordered pair, second ordered pair, first ordered pair, first ordered pair. So 4 minus 8 is a negative 4, 2 minus 4 is a negative 2. A negative 4 divided by a negative 2 is a positive 2. So no matter how you slice and dice it, the cat's going to be 2x. So when I write it, it's going to look like that. Which one's bigger? Obviously the 2 is bigger. Okay, now we're going to compare proportional relationships. So the cost for Y computer, this is the cost for Y computer repairs at computer access for X hours is shown in the table. Okay. Macro repair, macro is $23.50 per hour. Okay. Assume that the cost, so I'm going to go with Y equals 3.50 times X. Because cost is Y and X is hours. So Y is cost and X is hours. So I'm at cost per hour. Okay. So here, for every hour, I go up by 1. The cost is, 25. So it's plus 25, plus 25, plus 25. So I would have to say that computer access is $25 per hour. Well, because it's $25 for every hour, right? Because I'm at 50 here. I can even go backwards. 25 and 1. Go backwards, I get $25 per hour. Okay? So, $25 per hour. So now macro is $23.50 per hour. Sorry, $23.50 per hour. So which one's going to be the cheaper version? A macro repair is a cheaper version. Jingle bam. So now you have to do the checks. Here's what I want to let you know. Annie's current earnings are shown on the table. So this is going to be Annie right here. So label Annie out here. And then the new job is $7.25 an hour. Assume that's directly proportional. Okay, so I would do Y equals 7.25 for X over here. You need to find out what this one is here and share it in class. Actually, forget it. We'll do it right now. So if I'm going, let's see, what's going on between 32 and 25? I know this is going up by 1, right? What's happening here? What are these guys going up or down by? I'm going to put some pause and let you do some subtraction. All right, I figured it was $6.50. $6.50. So if I go backwards, if I do $13 on a $6.50, will it also be that? 12 minus, yes. So 1 unit's at $6.50. So I know that for this job here, Annie's, it's going to be $6.50 per hour. So which job is going to pay better? Boom, the new job does. Okay, you are now done. Boom. So this is kind of like those videos, those movies where they have like extra stuff at the end. It's like, you know, your Marvel movies. So here is it's a bonus movie. It's called the bonus phrase that pays, finger snap. Just like What's His Face did